Hello students. So today we solve current electricity chapter numerical. Okay, that's the solving 10 numerical and very important in boards exam. Okay, so here the first numerical is Ohm's law and resistance. The problem is the wire of resistance 5 ohm is stretched to double its length. Calculate its new resistance. So how to calculate new resistance? We know the formula is R equal to rho L by A. L is the length of wire and A is the cross section area of wire. Okay, so if that is the area A, cross section area, and that's the length. Okay, so length is double. So the length is double. So means rho twice L. If the length is double, stretch, so area be the half. Okay, because volume be the same. So that the area be the half. So A by 2. So and material be the same. That's a rho not change here. So rho 2 to 4 L by A and 4 rho L by A and rho L by A, that is 4 times R, that is equal to R. So here that the new resistance is 4 times old resistance times 5, we get 20 ohms. That's a very easy numerical. Okay, that's very important. Okay, that's the if when the stretch the length, material be the same, that's why rho be the same. When the volume be same, because that the length is double, so that if we maintain the volume be the same, that's why the area, cross section area be the half. Okay, that's the very important key point here. Next numerical is the resistivity and temperature dependence. The problem is the copper wire has the resistance is 6 ohm as 20 degree centigrade. The temperature coefficient alpha is given 0.004 degree per degree centigrade. That find the resistance is 80 degree centigrade. So the formula we know that is R 80 degree equal to R 20 degree 1 plus temperature coefficient alpha and the temperature difference. Temperature differences is 80 and 20, that is 80 minus 20. So R20 is given, that is 6 ohm. 1 plus alpha is given 0.004 times 60. So 6 1 plus 6 4 240. Okay, so here, okay, that's 5.004 times 60 point 0 cancel 24.24. So 6 1.24. So 1.24 times 6, 6 4 the 24, carry 2, 12 plus 2 14, carry 1, 7.4. Oh, that's a new resistance. Okay, resistance at 80 degrees centigrade. Okay, problem number 3. The series and parallel resistor. The 3 resistor 2, 3, 5 connected in parallel, find their equivalent resistance. That's a very easy problem. So 1 by RT, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 2 plus 1 by 3 plus 1 by 5. So LCM of 2, 3, 5 is 30. 2 is a 15, 3 is a 10, is 6. So that is 31 by 36. So the total resistance is 30 by 31 ohms. Very important. Maximum number is going to forget the reciprocal of this. That's why it's very important. So 1 by RT, that the formula is 1 by RT does not equal to RT. Okay. Maximum number student forget this 1 by reciprocal concept. Okay, remember that. Don't forget that. That's the final answer. Now question number 4, Kirchhoff's law. In a given circuit, find the current through 4 ohm resistor. Assume the simple circuit is 2-volt battery, 1 ohm and 4 ohm series, and 2 ohm resistor are in parallel with 4 ohm resistor. So 2-volt battery, 1 ohm or 4 ohm are in series. That's a 1 ohm. That's a 4 ohm. And 2 ohm resistor parallel with 4 ohm resistor. 2 ohm. Okay. So calculate current across 4 ohm resistors. I find. How to solve this? So first, these two are in series connection. That's why solve these two are the parallel connection. Sorry. So that's why first solve this. So that is the 1 ohm and parallel these two means 4 cross 2, 4 cross 2 by 4 cross 2 6. That is 4 by 3 ohm. A new circuit is 4 by 3 ohm. That is a 2-volt supply. And these two are the series. So 1 plus 4 by 3. So we get final connect circuit is that is 7 by 3 ohm. That is 2-volt supply. And find the current from Ohm's law. I equal to V by R. 2 by 7 by 3 means 6 by 7 ampere. And the current is 7 ampere here. 6 by 7 ampere here. Now the Kirchhoff's law states these are the junction point. If 6 by 7 ampere current goes in that direction, now the current is divided these two branches. And divided these two branches. Okay, that's a very important. Suppose there is a call X current and the current is 6 by 7 minus X. The total current is 6 by 7. One branch gets X, other branch gets 6 by 7 minus X. And now find the potential drop across these 4 by 3. And we know the current is 6 by 7 ampere. So the potential drop, so V, find V. So V that is equal to IR. So 4 by 3 times 6 by means RI or ISM 6 by 7 volt. So 24 by 21 volt. The potential is 24 by 21 volt. So V equal to IR. The formula is I times R. Now the potential drop across these resistor and potential drop across these resistor both are the same. And if you find that current across these, so you know the potential value the R. So without Kirchhoff's law, we solve this. I equal to find V by R. So V is 24 by 21 by R is 4. So 24 by 21 times 1 by 4, 4 by 1, that is 6. 6 by 21 means here, sorry, actually you can cancel this. 3 to the 6, or may same here. So 3 to the 6, 2 by 7. So get 2 by 7 ampere. If 2 by 7 ampere here, from Kirchhoff's law, we find the current across 2 ohm. That is current across 2 ohm. We get uh, 6 by 7 ampere minus 2 by 7 ampere. So we get 6 minus 2, that is 4 by 7 ampere. 4 by 7 ampere. And our final answer is 2 by 7. Actually, final answer is 2 by 7. I apply the Kirchhoff's law, find the current across these resistors also. These 2 ohm resistors. Okay. Now, the next problem, problem number 5, is the Wheatstone bridge problem. In Wheatstone bridge, PQRS is balanced. So we know that if I ignore the drawing, some point A on resistor, B point, that is P by Q, let's say that is R by S. Okay, and we know that is galvanometer current. This has a galvanometer I, that's at 0, means open. So ignore that. So P by Q equal to R by S. We know that formula. Okay, P is 100 ohm and Q is 200, R is 300, and S, suppose X, that's 2020 cancel. So X equal to 600 ohm. That's a direct answer. Okay. Now next problem is meter bridge, same as the Houston bridge problem. The balancing length is 40 centimeter on the left end, unknown the resistance X, and the known resistance is 10. So here the meter bridge problem is, the meter bridge is a 100 centimeter length, and you know that, and there is a balancing length is 40 centimeter. So here given is 40 centimeter. So other length is now 60 centimeter, and there is a known resistance is 10, is 10, and there is an unknown X. How to calculate this? Now to solve this, that is unknown X, that is equal to, you know that formula, there is a known resistance 10 times the known value 40 centimeter by 100 minus 40, that's 60. So that is 0, 0 cancel. So cancel 2 times 3, then 2. 20 by 3. So 6.67 ohm. Okay. The actual formula is, okay, R S L by 100 minus L. That's the unknown and there's a known resistance. That's the basic formula of the meter bridge. Okay. Next, number 7. The potentiometer of a wire length 400 meter gives the balance point is 1.2 meter. Standard for all cell is 1.5 volt. Find the EMF of the another cell balanced at 2 meter. Okay. So the formula is from potentiometer E1 by E2, that is equal to length 1 L1 by L2, 1.5 by E2 equal to, now the length 1 is a 1.2 and length 2, the balance at 2. Now E2, that is equal to 1.5 into 2 divided by 1.2. So point cancel. Okay, 2 the 6, 3, 2, 3, 5. So that is 5 by 2 is a 2.5 volt. Okay, that's the given answer. The answer is 2.5 volt. Now question number 8, drift velocity. Now the drift velocity problem, that's very important. Okay, so very important. So the current of 2 ampere flows through a copper wire of cross section is 1.1 into 10 to the power minus 6 meter square. if electron density is 8.5 into 10 to the power 28 per meter cube, find the drift velocity. So that equation I equal to NAE VD. So 2 ampere number of N. Okay. So here N cross section to meter square. So NE. Here the given the electron density. So here the given electron density is 8.5 into 10 to the power 28 per meter cube volume times cross section area 1 into 10 to the power minus 6 electron 1.6 into 10 to the power minus 19 times VD. So VD equal to 2 by whole things 8.5 times 10 to the power 28 10 to the power minus 6 1.6 into 10 to the power minus 19. Okay, and if you solve this with the help of calculator, and you get the answer is 1.47 into 10 to the power minus 4 velocity. SI unit is meter per second. You solve this with the help of calculator. Okay. Now the question number 9, heating effect of Joule's law. The power heater is 1000 watt, 220 volt is connected 110 volt supply, and the power consumed. Power consumed is power P. Okay, power consumed. Okay, power equal to the very important what? V times I. Okay, so the heater rated is a 1000 watt, 220 volt, and 110 volt supply. Okay, so current is not given here. So G I equal to V by R. So that is V square by R. So here V square 220 volt to 110 volt. So here not given here obviously. V square is given. There is a confusion. Power in 220 volt, 1000 watt and 220 volt connected 110 volt supply. So here the 110 volt square. Find the value of R. How to find the R is very important. R. How to find R? So here the R equal to V square by P. Similar concept here. From here we get find the R, that heated rated. Okay, the device resistance, that is 220 volts square. The power is 1000 watt. So now 220 times 220 by 1000, 20 cancel, that is 22 times means 484 by 10 means 48.4 ohms. Now put the value here, 48.4. Okay, so 110 square means you can solve this, that is 121. Okay, 12120 as another 0, 484. Okay, that's cancelled by that 11, that is 11,000. 444. There is 1000. There is a 4. There is a 250 power watt. That's the answer. Okay. Now solving the last numerical. Last is the internal resistance of a cell. Important. A cell of EMF 1.5 volt. Internal resistance is 1 ohm. Connected 4 ohm resistor. Find the terminal voltage. That's very easy problem. And if you know the formula, solving easy. V terminal voltage, that is equal to EMF minus I times internal resistance. Okay. So here the EMF is 1.5 is given. Current I, but here that terminal voltage. Okay. Current EMF is 1.5, resistance, internal resistance is 1 ohm and connected 4 ohm resistor. How to find the current value? Okay, EMF 1.4 and that total resistance, that's the important. Okay, how to find the current? I equal to 1.5 volt by total resistance 4 plus 1 5, so get 0 is 3.3 ampere. Actually the circuit look like this. There is a terminal resistance 4 ohm, there is a source and there is a very small internal resistance 1 ohm. Okay, actually they are, these two resistors are series, so that is 1.5 volt. Okay, that's not actually terminal voltage. Terminal voltage is this, and you know the current is 0.3 ampere, and you put the current value here. So 0.3 ampere times internal resistance is 1. So 1.5 minus 0.3. So you get 1.5, 0.3 minus. So that is 1.24. That's the easiest problem to solve. Okay. Test today solve the 10 very important numerical for board exam. If you have any doubt to solving this type of numerical, always ask in comment section. I will try to give the answer. Okay. First, clear the concept. That's very important. Concept clearance is very important. After clearing concept, solving numerical. And if you have get a NCERT book, Newton's book, HC Verma book, all books are very good. You take any one of them and solving all numericals. If you, when you solve the all numerical, then you solve basic numerical. JEE NEET exam numerical is easily you can solve that. Okay. That the KCL KVL problem, that's very important. We solve this type of numerical. How to approach to solving KCL KVL numericals. Okay, you watch that lecture. Okay, I put in lecture in I button, linked in I button. So today I wrap up the class here. Thank you.